Hi everyone, my name is Laura and welcome to my channel Haute Couture, dedicated to Houdini and digital clothing. The idea for today's tutorial came to me after I watched an amazing lecture by Laura Gallagher on her website Outgang. The tutorial was devoted to clothing detailing in Blender with specially made puckering brushes. When I saw the time-consuming process of getting seamless trim textures in Photoshop, I suddenly thought that the process will be much easier if we get the puckering not on a plane but on a cylinder. This would eliminate the need for manual adjustments at that step. I immediately tried it out in Marvelous Designer and it worked perfectly. But what if you try it in Houdini using a Vellum simulation? Let's take a look at how this could work. Here is an example of puckering setup in Houdini. We start with a tube. It shouldn't be too large because the size affects the results of the simulation, and we are working on a small closing detail, so we need to keep the size small. Next, we group the points of the open edges of the tube to pin them during the simulation. Then we set some basic parameters in the volume cloth constraint. If we want to get a lot of wrinkles, we need to slightly increase a rest length parameter. So each pair of particles will try to move a bit further away from their neighbors, but because their expansion is restrained by the pinned points, they will be forced to form folds and wrinkles. Two other important parameters are stretch stiffness and bend stiffness. The first one restricts the movement of points away from each other, while the second one controls the angles between connected edges. The lower the stretch stiffness and the higher the bend stiffness, the more wrinkles you can expect, and vice versa. You can use PDG to test different parameter combinations, but in my experience for tasks like this, it's usually faster to manually find the right parameters rather than render hundreds of combinations in search of the best result. In the Vellum Solar SOP, we set the gravity to 0. Once the simulation is done, we select the desired frame and, if necessary, smooth the geometry using the position attribute blur. Then use the match size node to centralize and normalize the scale of the piece. Next, we prepare a low poly mesh for baking the wrinkle details. It's also a tube, but I use the sweep node to create it because sweep generates a nice UV map. We create a normal attribute on the points, which we will use during the baking process. Next, we swap the U and V coordinates of the UV map because we are going to bake the ring into a ribbon along the circle but not along the tube's vertical axis, which is the default orientation of the UV texture. After that, we use match size again to centralize the geometry. The final step before the baking is to create a 2D volume. We position it on the XY plane within the 00 to 11 coordinate space. This way, we mimic the first UV tile's coordinates, allowing us to treat the voxels of the volume as pixels of a texture image. I used to bake in the SOP context using a volume wrangle. This method transfers geometry information onto a 2D volume, which is then passed into COPs. However, now this process can be done using a wrangle node directly within COPs, though I won't be covering that in this tutorial. Of course, it's not the only baking tool available in Houdini. However, I use it because it calculates quickly, minimizes problems, and allows control over the appearance of the resulting image. For the baking process, I use a standard VEX code, which I've already shared in my LinkedIn, but I will explain it here as well. With the UV sample function, for each pixel of the image, we find the position of the corresponding point on the surface of the 3D model, along with its normal vector. Next, we take each such point and, using the intersect all function, we send an imaginary ray along the normal from that point, and record data from the surface point it hits on the high poly geometry. We perform these operations in both directions, along the normal vector and against it, so we can cover both hills and forces of the high poly geometry. Once we get our hit point, we measure the distance between it and the surface of the low poly geometry, recording this distance information as a height map. We then send this information into COPS using SOP import. To interpret this volume data as an image, we use the Geo2Layer node. Then we add a contrast regulator just in case. If I want to ensure the texture is tileable, I add the tile pattern node with a 0 inset, division set to 1, and the column offsets at 0.5. This shifts the tile's border to the center of the image, allowing us to make sure that the texture is perfectly tileable. We can scroll through to verify that there are no visible seams. Lastly, we adjust the size and the position of our image using the crop node, ensuring the coordinates are correct for texture use. We select the texture option here, and now our trim texture is ready for export. Let's check how it works. To do this, we use a similar setup, but instead of height information, we capture the UV coordinates of the mesh we want to bake. We then use these UV coordinates to extract color information from the image located inside the COP network here. And again, it's important to have both the mesh we want to bake onto and the mesh we are baking from. We create the latter by sweeping a ribbon along a curve. Both meshes need to have UV textures. Here is how the result may look. We can also experiment with other brush textures that I prepared in advance. But that's not all. You can use this cylindrical method to create textures for any trim you want. For example, let's take a look at how it works for fiber. We start with a circle curve. Apply a series of p-scale and position noises. Then we perform a triple sweep to create the fiber structure, a principle I discussed in my LinkedIn when highlighting the power of the sweep SOP. Next, we generate a noisy set of flyaway fibers. This is how our fiber looks, and this is how it looks in the texture, and in the texture while being baked to a plane. Also, I want to emphasize that when previewing the COP material in the basic viewport, you can't use dicing. Therefore, it's essential to make your mesh dense enough to capture the high details. For example, my mesh here is set to 500 by 500 just for visualization purposes. It doesn't require to be that dense during render. Or you can do it in Solaris without this kind of problems. That's all for today. You can apply the cylindrical principle to create any seamless trim texture you want. I would love to see your results and hear your thoughts on the workflow described above. Good luck!